are creating this triangle book, and we've created a triangle. Each of us have a different one, probably. We are measuring the sides of the triangle. I did mine in inches. You could also use centimeters. And then I measured the angles with a protractor, and I just wrote them in the corners. Now I'm going to set this triangle aside for a minute while we do some vocabulary. Here we go. We can name triangles in two different ways. The first way, one of the ways we can name triangles is by how their sides are related. Okay? There are 4 different ways we can, angles. I said sides, and here it is saying angles. It's because I'm waiting for you guys to be quiet instead of reading my own paper. 5, 4, 3. You're mostly quiet. Okay, here we go. So there's 2 ways to name triangles, by their sides and by their angles. This page is naming triangles based on their angles. Actually, instead of calling it naming it, it's more like classifying is kind of the term we use, but I have name on here. So we're naming them by their angles or classifying them, putting them in classifications based on what their angles are. The first one we're going to talk about is called an equiangular triangle. What do you think that might mean? That would mean that all of the angles are equal. Okay, the next one, should we draw a picture of what that would look like if all the angles are equal?
Yeah.
Okay, let's draw a picture of what that would look like if all the angles are equal. Remember when you're drawing equal angles, you put a little arc in them like that, and that tells us that they're equal, right? Okay. The next type of triangle we're going to talk about is called an acute triangle. In an acute triangle, all of the angles are acute. What does acute mean again? Less than 90. Good. Let's look at the triangle we just barely drew. Are all of these angles acute? Yes. So even though this is an equiangular triangle, meaning the angles are all equal, is it also an acute triangle, meaning all the angles are acute? Is this an acute triangle and an equiangular triangle? Yes, it really is. Okay, so let's try and draw an acute one, though, that has different sized angles. Sometimes I have a hard time doing that. Nope. Okay, so in this one, all of the angles, notice how all the angles are less than 90. That one's pretty darn close to 90, but it's a little bit smaller than 90. Do they have to be equal? Do I need to mark them equal in an acute triangle? No, they could all be different. So I'm just not going to mark them at all. They're just look at them and make sure they all look acute. That's the important thing. Okay, in a right triangle has one right angle. Why don't you think a right triangle has 3 right angles? It wouldn't. Here, I'm going to try drawing a triangle with 3 right angles. Okay, here's a right angle, here's a right angle, here's a right angle. I just tried drawing a triangle with 3 right angles. What happened?
No, it doesn't connect.
There's no way that those can connect and make just a 3rd side, right?
Why can't it have 2?
So.
Wait, what if a triangle?
Okay, let's try it with just 2. What if we have a right angle here and a right angle here? Yep, that's a right triangle for sure.
No, that's a 90-degree square.
I don't know what that is. It's not connected. A triangle has to be connected, right? So if I have 2 right angles, it doesn't connect. If I have 3 right angles, then I end up with an extra side, and it's going to be a square instead. Do you just see how you can't have more than 1 right angle? It's just not going to work. Okay? So it only has 1 right angle. Let's draw a triangle with just 1 right angle. So one of your angles would have the box and be a right angle. What are the other 2 angles going to be automatically? Are you sure they'll be acute? Yeah. Are you sure they won't be obtuse?
No, yeah, they have to. Because then they won't.
Why can't I make this one obtuse instead? It's not going to come back and make a triangle, right? It has to be acute. The other two angles are acute. They have to be less than 90 or it's just not going to make a triangle. Okay, last one is obtuse triangle. An obtuse triangle has one obtuse angle. What does obtuse mean again? More than 90. Right angle was 90 degrees. Remember we learned that. One obtuse angle means greater than 90. Okay, so I need to make sure I draw a triangle with an angle that's obtuse. And there's my obtuse angle. What's the other two angles going to be? What are they going to be? Acute, obtuse, right? They will have to be acute angles, won't they? It's not going to work if they're not acute. So the other two angles are acute. All right, now comes the time you're actually going to use your orange triangle for something. Everybody look at your orange triangle with me and decide which classification it fits into for its angles. Is it equilateral? I mean equiangular. Sorry, I said the wrong thing. Is it acute? Is it right? Is it obtuse? So everybody decide what category your triangle fits into.
Oh, it's like mine is.
Okay, now hold your triangle in the air when I tell you to if your triangle fits into the category. Hold your triangle up for all of us to see if it is equiangular. If all of the angles are equal, hold your triangle up so we can see that all of the angles are equal. Equiangular triangle. Looks like we have one over there. Christian has an equiangular triangle. Anyone else have an equiangular one? Okay, cool. Sky, yours looks... No, Charles, that one's not equiangular. What does it have to have in order to be equiangular? Equal angles. And how do you know that the angles are equal? Because you measured them, remember? So, my angles are definitely not equal because one's 47 and one's 119 and one's 114. They're all totally different. So mine is not equal angles. No, those are sides, not angles. We're talking angles. Angles. You guys understand the difference between sides and angles?